This is a story you probably think you know. It's one of the most visible, most heartbreaking tragedies in the entire history of space exploration. But, underneath all the smoke and the sorrow, there's another story. A story about a fatal decision and a deadly truth that was hiding in plain sight, locked away in the data they chose to ignore.
So let's set the scene. It's Cape Canaveral, Florida, on January 28, 1986. And it's cold, unusually cold, but the excitement is absolutely electric. Millions of people, including an entire generation of school children, are just glued to their TVs. Why? Because they're about to watch Christa McAuliffe, a teacher, become the very first civilian in space.
At 11:38 a.m., the final countdown hits zero. And there it goes. The Challenger, this incredible symbol of national pride and human ambition, just roars to life. It climbs majestically, piercing that bright blue Florida sky. I mean, it was a perfect picture of triumph. But just 73 seconds later, at an altitude of 14 kilometers, that perfect picture shattered. The triumph turned into this, a catastrophic failure broadcast live on television that just seared itself into our collective memory. In the aftermath, this was the question on everyone's mind, right? How could something so advanced, so meticulously planned, fail so spectacularly? Well, the investigation would uncover a whole chain of events, but the root cause wasn't just a mechanical failure. It was a failure to understand the data. To really get what happened, we have to rewind to the hours right before the launch. A huge debate was happening between engineers and managers, and it all centered on one tiny but absolutely vital component. And that component was the O-ring. Now, you can think of it like a simple rubber washer, just an incredibly high-tech one. Its job was to create a perfect seal in the joints of the solid rocket boosters, keeping all that super hot, high-pressure gas contained. If that seal breaks, well, disaster is pretty much inevitable. And this was the big problem. The temperature that morning was just above freezing, way, way colder than any previous launch. Some of the engineers were deeply worried. They thought the rubber O-rings would get brittle in the cold and just fail to seal properly. They really tried to raise the alarm. So, the NASA managers, they looked at the data. And this right here, this is the information they reviewed. It's a chart focusing only on the 7 previous flights where some kind of O-ring damage had been seen. They were trying to see if there was a link between the temperature and that damage. And what did they conclude? Well, looking at just these 7 data points, the connection seemed totally random. You see damage at a cool 53 degrees, but you also see it at a warm 75 degrees. So, based on this really incomplete picture, they decided the data was inconclusive, and they gave the green light to launch. But that conclusion and the data it was based on was just fatally flawed. See, the problem wasn't the data they had. The problem was all the data they were ignoring. They weren't looking at the whole picture. I mean, it makes you wonder, right? The engineers looked at the flights with failures. But is that the only data that matters? What about all the flights where everything went perfectly right?
And this is the crucial missing piece of the puzzle. There had been 16 other shuttle flights where the O-rings had suffered zero damage. 16 successful data points that were completely left out of the analysis simply because nothing went wrong.
This is a textbook example of a really dangerous statistical trap called selection bias. It's what happens when you only look at a specific slice of your data, in this case only looking at the failures, and it gives you a completely warped understanding of reality.
So what happens when you fix that bias? What happens when you put all the data points, the successes and the failures, together on one chart? Well, a terrifyingly clear pattern starts to emerge.
And there it is. With all 23 flights plotted, the trend is it's undeniable. You can see this clear inverse relationship. The warmer the launch day, the safer it was. The colder it got, the more damage the O-ring sustained. Look at that. All of the perfect, no-damage flights happened when it was warmer than 65 degrees. Below that, it was a total minefield.
Now, this visual trend is powerful all by itself, but statisticians later went even further. They used statistical models to analyze this complete dataset, which let them move beyond just seeing a pattern. They could actually calculate the precise probability of failure at any given temperature, turning that scary trend into cold, hard numbers.
So, based on the full dataset, the statistical model predicted a staggering 74% probability of O-ring failure at that 35-degree temperature on launch morning. A 3 in 4 chance of catastrophe. Just think about that.
To put that in perspective, let's look at the risk on a more typical 70-degree day in Florida. The probability of failure then was less than 5%. The difference is just enormous.
In fact, by deciding to launch in the freezing cold, they increased the risk of O-ring failure by nearly 58 times. The data wasn't just suggesting it was risky, it was practically screaming that disaster was imminent.
The story of the Challenger is, of course, a human tragedy, but it's also a profound and timeless lesson about the power and, honestly, the peril of data. It's a lesson that goes way beyond the launch pad.
The takeaways are pretty simple, but they're so critical. First, you have to look at all the data, not just the pieces that confirm what you're looking for. Second, always be on the lookout for selection bias, for the information that's missing from the story. And finally, never forget that understanding data isn't just some academic exercise. As Challenger showed us, it can truly be a matter of life and death.
You know, this tragedy forces us to ask a question that is more relevant today than ever before, in a world that is just drowning in data. When we make decisions, in our businesses, in medicine, in our own lives, what are we not seeing? What crucial successes are we ignoring just because we're so focused on the failures? And what truths are just waiting to be discovered if only we look at the whole picture?